So we learned how to use trig to solve for missing sides in a right triangle, but you can also use trig to solve for missing angles in a right triangle. So for this, we're going to do the same process. We're going to highlight our hypotenuse, and we're going to label our sides. So circling my reference angle, in this case, you can see that the reference angle is X. I'm going to label my sides. So this is H, this is A, and this is O. And just like before, I'm going to look and see what information am I given and what information am I solving for. So in this case, we're given two sides, which is the opposite and the hypotenuse, which tells me I'm going to use sine. But in this case, the unknown is our reference angle. So sine x equals, we're still going to set it up opposite over hypotenuse. Okay, but for these ones, we're not going to cross multiply because that's not how we're going to get x by itself. To get x by itself, we have to use what's called the inverse trig function, which is basically sine -1, 12 over 17. So what we're going to do is we're going to actually put this in our calculator. So to get inverse sine in our calculator, we press the second button, and then we press sine. So you would just type in second sine, and then you would do 12 divided by 17 and hit equals. And when you do that, you should get your angle measurement, which is going to be 44.90. And since this is the angle, I'm going to put the degree symbol. Okay, so let's do the second one. Again, I'm going to highlight my hypotenuse, circle my reference angle, and label my sides. This is O, H, and A. And since I have my opposite and hypotenuse, that tells me I'm going to use sine. So it's going to be sine of our reference angle equals opposite over hypotenuse. So again, to get x by itself, we use the inverse sine. And this is what we put in our calculator. So we hit second sine and then 3 divided by 7. You get about 25.38 degrees. So these problems are even a little bit easier. All you have to do is press a different button in your calculator. All right, so let's look at the cosine ones. So same thing, we're going to highlight our hypotenuse, and I'm going to highlight at the same time. I'm going to circle my reference angles, and I'm going to see what information I'm given and label my sides. So 5 is the adjacent side, 9 is the hypotenuse. And then on the second problem, 20 is the adjacent side, 38 is the hypotenuse. So since both of these problems, we have the adjacent and the hypotenuse, that tells me I'm going to use cosine. So it's going to be cosine x equals, and then adjacent over hypotenuse, and this one is going to be cosine x equals 20 over 38, adjacent over hypotenuse. Then to put it in our calculator, we're going to use the inverse cosine. So we hit second cosine, and then 5 divided by 9. On the second one, it's going to be inverse cosine. So second cosine, 20 divided by 38. So the first one should get 56.25 degrees. And the second one, so we do second cosine 20 divided by 38, you get 58.24. Okay, tangent is done a similar way. We're going to highlight the hypotenuse. We are going to circle our reference angle and label our sides. And then we're going to see what information is given. So we have the 12 and the 5, 9 and the 2, and we're solving for our angles. So since I have the opposite and adjacent, that tells me I'm going to use tan. So tan x equals 5 over 12, and the second one's going to be tan x equals 9 over 2. And to solve for the angle, we use inverse tangent. So tan -1, 5 divided by 12, and tan -1, 9 divided by 2. So to get inverse tan, you hit second tan, and then 5 divided by 12. We get 22.62 degrees approximately. And then the second one, second tan, 9 divided by 2, we get 77.47 degrees. All right, so now that we know how to solve for angles, now we can completely solve a right triangle, which basically means solve for all the missing sides and all the missing angles of the triangle. So looking at example 1, the information that I have is the 19 and the 31. I can go ahead and highlight my hypotenuse. So the trick with these problems is you see whatever you have 2 of. Well, since I have 2 side measurements, I'm going to solve for the third side first. So the first thing I'm going to solve for is AC, which I'll go ahead and call X. And for this one, we actually don't even need to use trig. We could just use Pythagorean theorem. So you will need to use other theorems to solve for missing measurements for these ones. So using Pythagorean theorem, it's going to be x squared plus 19 squared equals 31 squared. So it's going to be x squared plus 361 equals 961. Now we're going to subtract 361 from both sides. So we get x squared equals 600. And then we're going to take the square root of both sides. So we get x is approximately 24.49. Okay, now we're going to solve for missing angles. So I'm going to choose angle A to solve for, and we'll call it y. So using y as our reference angle, 19 is the opposite side, 31 is the hypotenuse, x is the adjacent side. So for this one, I have all 3 sides, but we're only going to use the numbers that they give us. So I have 19 and 31, which is opposite, and hypotenuse, which means I'm going to use sine. So it's going to be sine y equals 19 over 31. So it's going to be inverse sine 19 divided by 31. That's going to give us y. So second sine 19 divided by 31. You get 37.80. So the measurement of angle A is 37.80 degrees. So to find the last angle, there's a couple ways you can do it. You could use triangle sum theorem now that we know that this is 37.8 degrees. Or you can use inverse trig again. So I'm going to use inverse trig since we just learned that. I'm going to call this angle Z. Using that as my reference angle, 19 is now my adjacent side, which means I'm going to use cosine. So cosine Z equals 19 over 31. So we're going to use inverse cosine 19 divided by 31. So second cosine 19 divided by 31, we get 52.20. So the measure of angle B is 52.20 degrees. So now we've solved for all the missing sides and angles of this right triangle. All right, let's look at example 2. So example 2 is a little bit different because in this problem we're given a side and an angle instead of the previous one, which we were given 2 sides. So for this one, the first thing you're going to want to solve for is actually the missing angle. So we're going to solve for angle y, and we can do this by using triangle sum theorem. So we have 44, we have 90. So 44 plus 90 plus y equals 180. So 134 plus y equals 180, and then subtract 134. y is 46 degrees. So the measure of angle y is 46 degrees. Okay, now we can solve for some missing sides. So I'm going to solve for YZ first, and I'm going to call that, I'll just use the letter A so we don't get confused with the angles. So highlighting my hypotenuse, I'm going to use 44 as my reference angle. So 10 is my adjacent side, this is my hypotenuse, and this is my opposite side. So I'm given my adjacent side, and I'm solving for my opposite side, which tells me I'm going to use tan. So tan 44 equals A over 10. And then we cross multiply. So A equals 10 times tan 44. We get A is approximately A is approximately 9.66. So that means YZ is 9.66. Okay, now I'm going to solve for my hypotenuse, which I'll go ahead and call that B. So that's my hypotenuse. I'm going to use the same reference angle. So that's adjacent and a hypotenuse, which means I'm going to use cosine. So it's going to be cosine 44 equals the adjacent side over the hypotenuse, and cross multiply. So B times cosine 44 equals 10 times 1, which is 10. And divide by cosine 44. So 10 divided by cosine 44 is approximately 13.90. So xy is 13.90. All right, so now let's take a look at a couple of the practice problems. So looking at number 2, we're going to solve for all the missing sides and all the missing angles. So in this case, the first thing I'm going to do is I'm going to solve for AC, which is the missing side. So I'm going to go ahead and call that x, and I'm going to use Pythagorean theorem. So x squared plus 18 squared equals 39 squared. So this is going to be x squared plus 324 equals 1521. And then subtract 324. And then we're going to take the square root. We get 34.60. So AC is about 34.60. Okay, now we're going to choose an angle to solve for. So I'm going to solve for angle A first. Highlighting my hypotenuse and labeling my sides. So this is adjacent, opposite, and hypotenuse. The information I have is the opposite and hypotenuse, which tells me I'm going to use sine. So it's going to be sine A equals 18 over 39. And using inverse trig, it's going to be inverse sine 18 divided by 39. So second sine 18 divided by 39 gives you 27.49. So the measure of angle A is approximately 27.49 degrees. Okay, now finding the measure of angle B. Using B, 18 is now my adjacent side, so that tells me I'm going to use cosine. So cosine B equals 18 over 39. So inverse cosine 18 over 39. So second cosine 18 divided by 39, we get 62.51. So the measure of angle B is 62.51 degrees. All right, let's look at number 4. So number 4, we have an angle and a side. So I'm going to first solve for the measure of angle A. So it's going to be A plus 40 plus 90 equals 180. So A plus 130 equals 180. Subtract 130 from both sides. So the measure of angle A is 50 degrees. All right, so now we're going to choose a side to solve for. I'm going to solve for AC first. So I'll call that X. So 40 is my reference angle. AB is my hypotenuse. And labeling my sides, this is H, A, and O. So I'm solving for my opposite side, and I have my adjacent, which means I'm going to use tan. So it's going to be tan 40 equals X over 11, and cross multiply. So X equals 11 times tan of 40. And then we just put that in our calculator. We get 9.23. So AC is about 9.23. Now I'm going to solve for AB, which is my hypotenuse. And again, I'm going to use my adjacent side. So adjacent and hypotenuse means we're going to use cosine. So it's going to be cosine 40 equals 11 over, and we'll call it y. Cross multiply. So y times cosine 40 equals 11. Divide both sides by cosine 40. (11) divided by cosine 40, you get about 14.36. So AB 14.36. All right, the last problem we're going to do is number 5. So it says a boy flying a kite lets out 300 feet of string, which makes a 38-degree angle of elevation with the ground. Okay, so here's the string. This is 300 feet. And the angle of elevation is 38 degrees. We want to know, assuming the string is straight, how high above the ground is the kite? So what we're looking for is that vertical length right there. Okay, well, I have my right triangle. I can highlight my hypotenuse, and I could label my sides. So this is A, O, and H. For this problem, I'm solving for my opposite side, and I have my hypotenuse. So OH means I'm going to use sine. So it's going to be sine 38 equals X over 300. So X equals 300 times sine 38. We get about 184.70 feet. So since it's a word problem, we should have a word answer. So the kite is 184.70 feet above the ground.